Hello everyone, welcome to today's training session. My name is George Roscoe. I am the product manager for Switchboards. Today's topic will be talking about switchboard space savings and design tips and tricks to get there. The WL combo section is a great way to save space. A WL combo section is a 38-inch wide section that combines a WL breaker, 2000 amps and below, with a 30 inches of unit space for group mounted devices. This section design can be used as a feeder or a main section. It can also be used with busway or cable with a WL breaker, incoming or outgoing. In order to have Compass use this design, which is default for mains when possible, is using service main and panel selection for mains and the branch combo option for feeders. This option drop-down is available under the WL breaker section tab. As a note, using combo section works if you can either group mount the surge protected device or utilize the metering plus function of the WL. If you need to use a pack meter or other meter, you will need to use the standard section for WLs, not the combo section. The selection for WL combo sections is under the WL main tab, as illustrated in the image. The example here shows where the option is for feeder WL breakers, namely under the section config option dropdown. One of the most common questions asked in switchboard design is, how can I reduce the number of sections? The image on the left shows one way to reduce a section. Both images have the same number of 400 and 600 amp circuit breakers. The top image uses Centron thermomagnetic circuit breakers. Thermomagnetic circuit breakers are the most cost-effective option and are among the most frequent used circuit breakers in switchboards. One downside of these thermomagnetic circuit breakers is that they are sometimes larger than electronic trip circuit breaker counterparts, specifically at 400 and 600 amps. One way to save a section in certain applications is to swap out the thermomagnetic circuit breakers for the VL electronic trip circuit breakers to see if a section can be saved. The savings per breaker in unit space is 2.5 inches going from thermomagnetic to electronic trip, which can add up quickly. And this illustration shows how you can save a section using that option. That option may not always work, so it should be experimented with to see, based on price and section, to get the proper balance. Another key feature illustrated here is a Siemens advantage. We are the only company that can dual mount 400 amps in less than 40 inches of section width. You can see that used several times here to save space and is a very big competitive advantage for us. This specific example shows 400 amp breakers mounted in 38 inches wide sections. That is a key advantage to save space, in addition to the previous discussed thermomagnetic and electronic trip space saving balance. Switching from a thermomagnetic breaker to an electronic trip breaker is as easy as changing the configuration on the main circuit breaker page. Under trip unit type, you see there is the selection for thermomagnetic. To change it to electronic trip, just select the solid state option and now you'll have a solid state circuit breaker. Another key Siemens advantage versus the competition is center-fed distribution sections. These sections allow for up to 4,800 amps of breakers to fit in a single group-mounted distribution section. It can be used to maximize the number of breakers in a section, especially when there are several breakers that are 400 amps or greater. The key design feature is the bus connection comes in at the middle of the section. A center-fed panel can easily be discerned by finding the 2.5 inches of restricted space in the middle of the panel, as you can see in the bottom image. Center-fed distribution sections are usually defaulted to Compass when necessary, but can be selected in the main options tab in Compass by selecting panel layout, then in the drop-down center feed. The two images above show the competitive advantage easily. The upper picture shows 4 1200 amp feeder breakers taking up 2 sections. This would be very common with our competition's offering. With our center-fed distribution section, we essentially create 2 panels in one section. In doing so, this allows us to fit 4 1200 amp breakers in one section versus the competition's 2, which is a huge Siemens advantage. This slide shows where you can select center fed option in Compass. It is at the top level of the tree and under the Options tab. If you select center fed, that will make every section that is distribution have the center feed option. I don't recommend usually forcing it to this option because Compass will normally discern which one is better on its own, but it can be done if needed, and there is how. Another great space-saving option is the 2-high WL configurations. The 2-high WL configuration consists of up to two 2000 amp WLs stacked on top of each other in a single section. At 30 inches deep, this option requires the top WL cables to go out the top and the bottom WL cables to go out the bottom. This section saves up to 38 inches of space, and in Compass it's easy to configure by selecting 2 key options. The first is under the WL breaker, select branch 2 high, and then in addition, select the device position, top or bottom. In order to ensure Compass lays it out appropriately, make sure one of the WLs you wish to group mount is selected at top and the other at the bottom. This will ensure a nice smooth layout. In addition to the standard design where one cable goes out the top and one goes out the bottom, Grand Prairie has a custom design for 48 inches deep to allow both cables to exit the same end. The one caveat is that, for example, if you want both cables to go out the top, the through bus will need to be at the top, and if both cables need to go at the bottom, the through bus will need to be at the bottom. This design is very flexible and has been available in Compass for the last few years and is available today. On this slide, it illustrates how to select the 2-high WL configuration option. It is under section configuration of branch breakers. You select branch 2 high, and then right next to it will appear the device position, which, as mentioned previously, one needs to be on the top and one needs to be on the bottom to lay out appropriately. Another option for value engineering is the use of series ratings. This is an example of a 208Y 100 kA system. We have a price-sensitive customer who wants the lowest cost panel available. Series ratings are a way to reduce the cost of the panel significantly. Be careful using series ratings in certain applications such as hospitals, facilities where they may not be allowed. Also be careful if series ratings upstream could impact downstream circuit breakers, so be very careful when using them, but they will offer value when you can use them. In this example, we have an 800 amp main with 125 to 400 amp feeders. Utilizing series ratings with the main to the feeders can save about $1,000 net, or about $9,000 list on the panel. So this is a very good price configuration option where allowed. One of the keys in a switchboard design is wherever the incoming lugs are, the through bus runs opposite that incoming direction. For example, in the image on the left, the cables come in from the top. This means the through bus will be at the bottom. For individually mounted feeders, this means outgoing will always need to be at the top of the switchboard. As we know, reality is never this clean, and there may be a need for some feeders to be bottom outgoing and some top outgoing. In the right image, it shows an example of this. In the old days, if an incoming was at the bottom and we wanted the feeders going out the top, we would have had to add a pull section, making the board wider and adding cost to the board. And consequently, if we wanted through bus at the bottom and a feeder going out at the bottom, we would have had to add a pull section for that feeder. As we know, with ever-shrinking electrical rooms, the idea of adding pull sections is undesirable. A new design called inverted mains and inverted feeders can now have cables or busway outgoing the same direction as the through bus, saving a section. It can be done on mains or feeders, including WL mains and feeders, molded case breaker mains and feeders, and voltage pressure switch mains and feeders that are mounted individually. It is recommended when designing a system to maximize individual mounted devices to go out the direction opposite the through bus and utilize inverted mains and branches sparingly to fill in the gaps. This way it will have the least amount of cost impact to your design. In Compass, under Section Type, it is easy to find the inverted mains and branch options. It is under the Section Config / main section type options as inverted mains or inverted branch. The great thing about inverted mains and branches is this selection can be made after layout, will not require an additional new layout. The layout will automatically flip through bus direction or flip the lug pointing direction instantaneously, keeping it a simple, easy tool to use when doing value engineering. In summary, with recent Compass upgrades, it is easier than ever to save space and money in your design. Utilizing the tips and tricks discussed today will save space, save money, and increase your customers' overall satisfaction. If you have any questions on what you've learned today, please contact your local Siemens representative for additional information. Thank you for your time and have a great day.